And so a lot of you guys, everybody still has that available to them. So we can do that. So here are our lessons. We have all these things. All of these things that you see right here are all about one thing, and that's taking a derivative. Everything there is just about taking a derivative. That's all it's about, okay? So those are all kind of together. The one other thing we want to add in is we talked about this briefly before, but right now we're going to talk about motion. We're going to talk about a position function, which is s of t, and a velocity function, which is v of t. We choose the variable s for position. We choose the variable v for velocity. And it turns out that velocity is a rate of change. A rate of change is a derivative. The way that we get the velocity function is we take the derivative of the position function. So in this first example right here, a particle is moving according to the law of motion, s is equal to this function. T is measured in seconds, so seconds are going by. S is measured in feet. It says that we're going for time greater than or equal to 0. Everybody agree it's okay to not talk about negative time? That would be kind of like Back to the Future or something like that, which would be totally cool. But we're going to keep time positive here. The first question is find the velocity at time t. How do we do that? We simply take the derivative of the position function. And now you know how to do it. You never need to use x plus h minus f of x over h anymore. What's the derivative of our position function? Yeah, doesn't that feel nice to just say it and be like, okay, all right, because we're ready to move on to this application piece and whatnot. Particle at rest. When does that happen? Well, it turns out that when the velocity, see we have velocity that's positive if we're moving one direction and negative if we're moving another direction. You tell me what my velocity is at 0. When I'm changing direction, right? So particle is at rest when v of t is equal to 0. So we want to find those times. That's important for us. And then particle is moving in the positive direction when the velocity is greater than 0. And the particle is moving in the negative direction when the velocity is less than 0. Okay. And you're seeing this right now. We see this actually 2 more times throughout the year. So this will be a fundamental building block that we build upon. I'm going to first graph this function s of t, and I know it is a cubic. What shape does a cubic make? Yep. I'm going to find out where it crosses the x-axis. I'm going to do that by factoring out a t. So as I factor out a t, who can tell me what are the spots where it's going to cross the x-axis? Anybody want to take a guess there for me? 0.
4 and negative 3. I don't know.
Plus or 3.5 y. Yeah, plus or minus the root of 12.
Let's go.
Everybody see that? Okay, so 0 and plus or minus the root of 12, which is approximately 3.5. So let's sketch negative 3.5, positive 3.5, and 0. You're not going to have to do this for all of your problems, but I am showing you things that are going to really help us tie together what we did in the last unit with what we're going through now. So that's an approximate shape of my cubic. And I'm not talking about this back portion. Why am I crossing that off?
It's going to be greater than 0.
Exactly. Time is not negative, so we're all good to go there. Okay? All right. Now is where we need to really focus. This is definitely a day where we got to stay in line together. Okay? Here is my here's my function. And we see that is the derivative here, is the derivative here positive or negative? Negative. So am I traveling to the right or to the left?
Left. It's just
Left.
0.
So I'm traveling to the left, okay? What's the derivative here?
0.
0. So that means I am at rest. Here the derivative is positive, so I'm traveling to the right. So at this spot is where I am at rest and I change direction, okay? Good. Excellent. Okay, so let's go on to a couple easy questions and then we'll get to the other graph. We see that this is our velocity function. Suppose it wanted to know the velocity at 3 seconds. How do we compute that? Plug in 3. And I get 3 squared is 9, times 3 is 27, minus 12 is 15. And because it is a derivative, a rate of change, we should apply a unit of measurement to it. So a rate of change, this is going to be measured in feet per second. So do you remember last unit where I had you guys write those descriptors? You know?
Yeah.
And so that's what this is just trying to lead you guys to understand, is that derivatives being a rate of change. Put a label on it. Okay? Keep it as simple as that. I didn't think I needed to put it on the test. Or should I have? We could maybe we should do after every test, we should make up the test for next year's class. We can make it as hard or easy.
I say add it.
Good fun.
Add
Yeah.
it.
All right. So now, before I go to this next part, I want to talk about when the particle is at rest. I'm going to actually draw the graph of v of t. And I notice that v of t is 3t squared minus 12. What shape does that make? Parabola. And if we were to factor this, we get 3 times t squared minus 4. Or 3 times t minus 2 times t plus 2. So does everybody agree this parabola travels through negative 2 and positive 2 on the x-axis? And we're going to go ahead and get rid of the left side of that because time is positive. Okay. This is where we need to be on the same page and try to get this in right at the right time before we leave here. This is my velocity function. Right here is the velocity positive or negative.
Positive.
This is the velocity function. Am I above the x-axis or below it? Below. Is the velocity positive or negative? Negative. Watch how this correlates here. Okay? Position, the velocity is the derivative. Is the derivative or positive or negative right here? Negative. That corresponds with this being below the x-axis. What's the velocity here?
Well, 0.
0, which corresponds with that. What's the velocity here? Which corresponds with that portion. So remember when we did our test and we talked about graphs and their derivatives?
Yeah.
This is where we kind of want to piece that together. We'll come back and pick up with that when you guys get back from lunch. What is for lunch today?
No idea. We're about to find out.
I think it's tacos.
Beefy tacos.
Yay! That's what somebody said.
Are you?
Considering Diet Coke, like the chemical balance in your brain is ingredients and the consumption. Oh,